Today I get to work on a vintage 1.5 horsepower single phase peerless motor. This bad boy is from the 1940s and was built to last. Now remember, this is a demonstration video, not instructional, so don't try this at home. First thing I like to do is punch mark the front and the back of the motor. Punch mark 1 on the front end on the bell itself, and then on the stator, and then 2 on the back end on the bell and the stator as well. That just helps for realigning it when putting it back together. Next I use my caliper to measure the exact location of the pulley. Since I'll be removing it, I want to make sure it goes back in the same position I take it from. This is also a time saver for when the motor is reattached to the unit. No time will be wasted realigning the pulleys. Now I'm going to remove the 4 bolts from the front end bell here to go ahead and break that loose. Also, while I'm up here, I'll go ahead and remove the grease zerk because I will be replacing it with sealed bearings and we don't want them greasing those. So this will be plugged, and having the grease zerk out will help for cleanup as well. On the back I notice a broken head off a bolt here, but it looks like the bell will slide off over it, so I'll go ahead and take off the other 3 bolts and see what we have. I'm also going to remove the grease zerk from the back side. Using my chisel and a hammer, I'm going to lightly tap against the back here on the lip to get the bell to break loose. Once I got enough of a gap on there, I'll use a couple of pry bars to get in there and work it the rest of the way off. Now I get my first look at the inside, and boy is it filled with dust, probably collecting since it was originally installed. I'm guessing that's probably the problem. Go ahead and take a brush here and clean off the contactors so I can check with the switch and see if it has continuity. I like to mark them with a marker so when I take them off I can put them back on in the same spot. It doesn't necessarily matter on these, but sometimes the leads are cut to size, so it just saves a little bit of hassle in the future. Simply mark them with 1 and 1 and 2 and 2. Now using a pair of needle nose, I'll go ahead and disconnect the switch from the motor. Luckily for me, this broken bolt is just hand tight in there, so it comes right out. I do notice that there are a couple of frays on this lead here. It's not broken through, just broken through the insulation, so I can fix that with just some shrink tube. Next I'll be using my multimeter here to check the switch for continuity. My guess is that there's so much dust in here that it's not going to be very good. To do the test, you just push down both arms to complete the circuit and see if you got continuity. On this one, it's kind of giving me a slight reading, but not very well. It's definitely enough to stop the motor from starting. I'll take the air hose here and blow it out of there and recheck the continuity just to see if that's what the problem is. Now when testing it, you see I get continuity right away. Before removing the switch, I mark the same markings I have on the switch to the outside of the bell, so that way when I put the switch back in, I just know it's in the same spot. There's only 2 bolts holding this in, so we pop those out and the switch is free. Now using the hammer and chisel, we'll break the front free. Get our cradle out here to set it in to keep it from rolling, pull the baffle off and set her aside. With that aside, we can see all the way through the motor and see, yes, the dust did go all the way through it. Here's a closer look at the cracks in the insulation on the lead, and also we're going to go ahead and remove this old wire nut from the bottom here. Using a 2 or 3 jawed puller on this pulley would just accomplish the task of breaking it. So I'm going to have to shimmer her up and use the hydraulic press to get her out. But first we're going to start by removing the set screw in here that holds it in place. Next we'll spray a little bit of WD-40 down in there just to let it soak in and hopefully help with breaking it free. To make sure I don't break the pulley, I stuck a bearing splitter back behind the lip, the fat lip of the pulley where it's going to be putting all the pressure, and then I braced that off with a couple of other metal bars. Now I simply go ahead and put a rod on there to help it push it through, and using the hydraulic press the pulley right off of the shaft. I use a bucket with some old copper windings underneath it to keep it a cushion to fall, so when it falls out I can keep my hands clear and it doesn't damage the switch on the back of the rotor. As I take the pulley off here, you can see how it was braced. That part there was up against this fat part here that kept it from pushing against the actual edges there and snapping them. I'm going to go ahead and take the spring load or wavy washer out of the rear bell here. Let's give one more good lick here before we start the cleanup process. Which we simply start just by using an air nozzle and blowing the loose dust out of here. Now we can get a better look at the inside here, a little closer look at the winding, and as you can see it looks pretty good, a little dusty, but there are no dark spots, no burnt holes, no copper laying in the bottom. It looks pretty good. To get the rest of the dust out of the inside, I'll spray it with some electric motor degreaser, which is non-conductive, and then I'll use a soft brush to work that around and get it cleaned up. I also use a piece of Scotch-Brite that I'll use at the bottom here and around the outside lip, not on the winding itself, just on the metal on the inside of the stator there to help clean up some of the rust and dust around there too. And once again, I'll use the trusty old air nozzle to blow that out of there and make sure it's all dry on both sides. Now I'm going to pull the leads together and put a little piece of tape over them so when I re-insulate the inside of the stator and the winding here, I'm not painting the leads. Using my red insulation varnish, I'll paint this from the inside out just to avoid a mess on the outside of the metal there and get it recoated. This will help to protect it from moisture and rust and other contaminants in the future. While that dries, I'll move on to the rotor. I start by cleaning up the extra grease here on the outside of the bearings to get it ready for pulling them off. I like to use these Posi-Lock 3-jawed pullers because they seem to work real well, and a lot of them come with this built-in shaft protector. You just slip it on there and it damages it keeps the front of the shaft from getting damaged as you pull the bearing off. Ignoring all the dirt in here, you can see that where the bearing rides on the shaft there is actually pretty good shape. Don't see any pits or any wears, so I think we'll be alright once we get her cleaned up. check the size of the bearing to make sure we put the appropriate size back on. And do the same thing with the rear bearing. Be careful when you're putting the puller on there to not get the centrifugal switch there. Just get right behind the bearing and pull from there. Now we test the centrifugal switch here to make sure it's popping back like it's supposed to. It clearly is. And check both. This one has two different arms to it, so we're going to check both of those and make sure they're connected good, and all looks good there. I'm gonna push the centrifugal switch back here and use this rag to get that extra grease out of there, and then we'll get the air hose and clean this thing up. Degreaser works great for cleaning up the rotor as well. The drive end is looking a lot better. Now let's move on to the rear. Now this may seem like a long, drawn out, tedious project, but I tell you, it is worth it in the end. Cleaning up like this, paying attention to the detail, getting the dust and stuff out of there will make this motor last. Now we're going to move on to the end bells and do the same thing there. Get the extra junk out of them here before you take them to the parts washer. I use a flathead screwdriver to get the grease out of the groove down inside the bells. From there we go to the parts cleaner there to get all the extra grease off to make sure it's good and grease free. Next we rinse them off to get off all that extra residue and hopefully all the grease. And then after that, we take them over and we dry them with the air compressor and the air nozzle there. Now when drying these, you want to make sure and get them completely dry because they're going to be repainted and we don't want to be trapped in any moisture inside. That will just create rust sooner. Sometimes even after the parts washing tank, you can still see some grease in there. So we got to get that out of there. This is where the degreaser will come in handy. Next, I'm going to clean up all the polished metal surfaces on here. We'll get here on the inside, around where the bearing rides, and then of course on the outside, and we'll get the outer lip as well. The bells are clean and are almost ready to be sprayed again. But before we do that, we need to tape off the middle here so no spray paint gets into where the bearings ride. I'm spraying these down with the same red insulating varnish that I used inside the stator to protect that and the winding. It just helps to keep it from rusting and also helps keeping contamination from sticking to the inside. They're starting to look new again. Next, I clean the grease off the spring load here, and then I'll move on to the pulley, get it all cleaned up, and get it ready to be painted. I have a wire brush on a drill that I used for cleaning the inside bore here to get back to the polished metal. I'm using a damp cloth here just to get the rest of the dust off of it. Time to turn on the bearing heater. While that's warming up, we'll go ahead and get the bearings ready over here. I got this marking pin here. It's kind of a wax marker. When it heats up to 250 degrees, it melts, and that's how you know that the bearing's expanded enough to slide onto the shaft. Now that the warmer's warmed up, we'll put the bearing on there and wait for the wax to melt. It's going to take a few minutes for that to be ready, so in the meantime we'll go ahead and take a little bit of oil here and put it on the drive end of the shaft and on the opposite drive end, right where the bearing is going to be pushed onto. That way just kind of helps it slide into place. Alright, the wax is just about melted here. And it is melted. So we're going to grab it with a glove protected hand and take it from the cone heater and go over and put it onto the shaft. Not the first time. Let's try the second time. Didn't let it get quite warm enough. There we go. Take the second bearing for the opposite drive in and get it on the warmer. And you can see that that's about melting away. There it goes. Now we'll take it and slide it onto the opposite drive end. Give it a little second longer after it melts this time. Boom. New bearings installed. Don't forget to shut off the heater and put on the protective cover. Next, we're going to use the degreaser and clean up the stationary switch. I'm going to use a little piece of emery cloth to get in here between the contacts on both sides of the switch, just to clean them up, get any contamination off them in. So we already know that it's making continuity, but we still want it to be cleaned up. It's always good just to double check the continuity once again and make sure we're still where we want to be. Looks good. So here we got all the parts cleaned and prepared and getting ready to go back together. So let's go ahead and take the tape off the leads here and get that aside. I'm going to go ahead and cut off both of the flags on here. We're going to replace them both to just make sure that we have a nice clean connection to the start switch, but also it's much easier to put the shrink tube on without the flag in the way. Next, I straighten out the leads a little, and then I'll take the shrink tube, put it on, and heat it up until it's properly seated. Next, we strip back the ends of the wires so we can put new flags on there to connect to the stationary switch. Next, we'll reinstall the stationary switch to the opposite drive end using the same two screws that were there before. For reinstalling the baffle, I found that it's pretty easy just to use a small piece of masking tape and tape the baffle in place. Otherwise, as soon as you try to put the bell up, it's going to just fall right back out on you. So I'll just put a little piece of tape here, make sure and tape it underneath the lip there so it holds it in place, and then bring it up and around. After the installation, we'll just tear off the top piece. And now I'll take the rotor and slowly slide it into the stator, taking caution not to hit the winding with the metal of the rotor. We don't want to damage the winding in any way. Now I look at the punch marks on the stator and on the end bell to make sure when I hook the switch up I got the bell in the right position. I line them up and then go ahead and reconnect the motor to the switch. There we are, the switch is installed and connected, and now the rear end bell is ready to be installed back to the stator. So we'll go ahead and get her into place here, position, put her on, slip it over the rear bearing, and use a little dead blow here and just lightly tap her into place, making sure that the punch marks on the top and on the bell are lined up. Went ahead and replaced the bolts on this since we did have one broken one. That's one thing I did update, is we got brand new bolts in for the front and the back of the motor. And now I'll put on the front end bell in the same way. And we'll tear off this tape to finish. And give her a quick spin to make sure it spins freely. Now it's time to move on to the junction box. We'll start by removing this here and taking out the start capacitor, making sure to take note of the microfarad rating and the voltage, which you can normally find written on the side somewhere in an area like this. I'm going to use a couple of zip ties to mark which two leads go to the capacitor. I'll use both blue because it doesn't matter which side goes to which lead. I mean, one to one side, so in this case it doesn't make any difference. Now just take some side cutters and just go ahead and cut them free from the capacitor. And finish removing the capacitor bracket. Next, I'm going to remove the two screws that hold the junction box to the stator. That way we can go ahead and remove it and get it cleaned up and ready to go back. Now when removing it, just make sure you take your time and be careful so you don't get any wires pinched. You don't want to tear or slice any wires on the way out, especially if there's some of the older nylon wires. I'm going to go ahead and take a quick minute to clean this rust off of here. Now using a wire brush, I'll clean the outside and the inside of the junction box. Now that that's cleaned out, I'm going to spray the inside of it with the same red insulating varnish that I've used on the other parts, just to protect it from corrosion and rust. While that dries, I'll go ahead and take a little bit of time here and finish cleaning up the outside of this motor. I want to make sure we have all the dust and debris off of it so we can get it repainted and have it looking good. Next, I install set screw plugs instead of grease zerks because we have sealed bearings in there and they do not have a reason to be greased. And I'll finish wiping it down with some Scotch-Brite, just like I said, to get the extra dirt and everything off there. Flipping it up on the back side, check the bottom and get that all cleaned out in there. And then we'll be ready to reinstall the junction box. The junction box is all dry, so now I'll carefully feed the wires back through and reinstall the junction box back to the side of the stator. And now we get ready to install the capacitor, but to do this, first thing I'll do is cut off all the ends of the existing leads and put new flags on where flags are needed. And now I'm ready to reconnect the leads to the capacitor. We'll put the cover on and tape it in place. Since this capacitor is a little narrower than the original was, we'll use a little black tape and put it over the top, and then we'll take it and wrap it around the sides just to keep her in place. And reinstall the capacitor back into the box using the same capacitor support that held it before. Now I'm going to go ahead and disconnect all the connections they had made inside the box here. They're not in the best of shape. So I'll disconnect them, cut off the eyelets, give it a nice clean connection back. That way when they go to reconnect it, they don't deal with the old hardware here. Now as I'm twisting these wires back up for them, I always like to take and put red zip ties around the power leads. That way it just doesn't cause any confusion. You can hook one power lead to one red and the other power lead to the other. It doesn't matter which one to which, you can interchange them. And all the wiring's done, it's time to hook up my leads and test run this motor. Sounds good. Now I use a little piece of emery cloth while it's running just to clean up the shaft real quick. Get all that extra rust and marks off of it. Then I like to grab my amp meter and go ahead and check the amp readings on both legs to make sure we're in the expected tolerance. Looks good. And I always like to run it a second time, so here's another angle, and I'll polish it again just a little more with this run. Now when you disengage the power on the test run, you want to listen back here for the click that the centrifugal switch makes as it slows down. Now we'll get all the leads put into place inside the junction box, and since they did not send the lid with it when it came, we're going to go ahead and tape all this off so we don't paint the inside of the junction box. And then we'll go ahead and tape up the shaft and the nameplate and get her ready for paint. Now when putting the tape onto the shaft, it's best to put the sticky side out. That way you can just roll it on, and then afterwards, when you're done and everything's dry, you can just grab it and it pulls right off. Now stand the motor up and begin painting. Once I'm done painting, I'll put it in front of the fan and let it dry. While we're waiting for that to dry, we'll go ahead and clean up the pulley a little more here, and then we'll tape off the inside of the bore. That way we can get it painted. When taping up the bore, I like to put the piece of tape over the keyway first and use a thin tool to just reach in there and push the tape down into the keyway and then come along the sides. Just a trick to help keep paint out of the inside of the keyway as well. And now that it's all taped up and cleaned up, we'll give it a fresh coat of paint. We're just going to paint the outside. We're not going to paint inside the grooves where the pulley rides. So if you paint from the inside out like this, you keep the paint out of the grooves. Next, I'm going to clean the rust off this key real quick just to give us less of a chance of the pulley snagging on a piece of rust or something when we're reinstalling it. Now that the first coat of paint's dried on the pulley, we'll flip it over and paint the other side. Same way from inside out. Now that the paint on the motor is dried, we'll go ahead and remove the tape. And here we have us a shiny, new looking motor built in the 1940s. Now it's time to reinstall the key, cover the shaft and the key in some anti-seize, and reinstall the pulley. See, as I'm putting it on with the dead blow, that the key is moving with the pulley back into the keyway and then sliding up, thus jamming the pulley. So I have to re-pull that out and figure out what was causing it, and it turned out that there was a second set screw down inside the pulley that I didn't notice. I removed it, and then the pulley went on with ease. Putting it back into proper place using the caliper and the measurement from when I took it off. Now tighten down the set screws and we are finished. We'll go ahead and give it one more final run here with the pulley installed and see how that goes. Alright, back on my bench, I'll reconnect the leads and we'll give it one final spin. Alright, it sounds good, it's running smooth. Any vibration I hear I know is just because it's not bolted down, it's just sitting loosely on my metal top to bench. So this is what I call a successful repair. It's a good running motor. They'll probably get another decade at least out of it. Well, thank you for watching. Be sure to check out my other videos and let me know if there's any kind of videos you would like me to make for you. Have a good day.